Alright, so in this we're just going to put these first two sections together and do a couple problems. The first one is the law of sines. And this is a really handy theorem because you don't need to have right triangles or anything like that, just any old triangle. And when you read the book, you'll see how they derive it. But really, it's just the ratio of the side and the sine of the angle opposite, that those, if you take that ratio, they're all equal to each other in all the triangles. And it doesn't matter if you, because this is the top one is really the common way that you see it written, but you can also just take the reciprocal of every side and get exactly this one. And it's really, there's no real which one is better than the other one. It's just which one you happen to remember or which way is the easiest way to set up. So let's try a couple problems with that one. So let's try this one, number 62. Number 62. A communication tower is located at the top of a steep hill. The angle of inclination of the hill is 67 degrees. A guy wire is to be attached to the bottom of the tower and to the ground at 165 meters downhill from the base of the tower. The angle formed by the guy wire and the hill is 16 degrees. Find the length of the cable required for the guy wire to be the nearest whole meter. Okay, so if we repeat our little diagram here, we have, this is 16 degrees, and this is the hill, but we could put a base in like this. So this is 67 degrees, and we know that this is supposed to be 165 meters down the hill. So that's that length like there. What we want to find is that length on that side. So of course we're going to use the law of sines to do this, because we know that we have the ratio of the sine of this angle and this, and of course we could get, but we need to know what this angle is because that has to be opposite this one, right? So we have and we can find, so we need to find these two angles, this angle here and that angle there. Now this one, if I draw a perpendicular, if I just draw this auxiliary line, that's a perpendicular that goes in like that. So what that does is that tells me that the angle here, this angle here, this thing is 16 plus 67, which is 383 degrees. So that means that this angle up here is 90 minus 83 degrees, because we're inside of a right triangle, so the angles are complementary. So this gives me 7 degrees right here. Now this angle right here, the sum of the angles of the triangle is 180, so this one would be 180 minus 16 minus 7 degrees. That would be 180 minus 13, or 7. This would be 17, so that'd be 167 for that side right there. Now we can set up the law of sines. So I know x over the sine opposite is the 167, and that's this side opposite, which is 165 over the sine of 16 degrees, or no, 7 degrees. This side right here, because that's opposite this side. So multiply that over the sine of 167. So I have 165 times the sine of 167 degrees over sine of 7 degrees. The 65 times the sine of 167 angle degrees divided by the sine of 7 angle degrees, and we get 304.5, and I believe the directions said round to the nearest integer, so 305 feet. So we have 305 feet when we round off to the nearest integer. Now let's try this one, number 60. Number 60. Determine how far a boat is from shore. Two radar stations are 500 feet apart. Uh, 70 degrees, and we have the figure for 60 degrees for this one. Alright, so we need to just find how far, determine the distance the boat from the station A and the distance from the boat from the shore. Round your answer to the nearest whole foot. Alright, so they want to know to station A, so in other words this side right here. So what we need to course is this angle, which is just 180 minus 70 minus 60, or 180 minus 130, which is 50 degrees. Right, so law of sines, we have sine of 50 degrees over 500 is equal to the sine of 60 degrees, because that's the side opposite of x. So we multiply this over, take the reciprocal, multiply that side over, we get 500 sine of 60 degrees over the sine of 50 degrees times the sine of 60 degrees, even though that's one we should know. We'll just plug in the calculator. Sine of 50 degrees is not one we should just know off the top of our head. And we get 565. .565 feet. Okay, the law of cosines is a really handy tool as well, because it's a generalization of the Pythagorean theorem. You know, the Pythagorean theorem says that if you have a right triangle, and then you know that the square of the sum of the square each leg and add them together, you get the square of the hypotenuse. Now, what I mean by generalization is that this no longer has to be a right triangle. So, because notice that if the alpha, for example, is 90 degrees, or for a right triangle, the cosine of 90 degrees is 0. So this term goes away, and you do have exactly the Pythagorean theorem. So this does calculate the sides, but you can also do angles if you happen to know all the sides. Herons' formula is a way of just taking the sides of a triangle and calculating the area by knowing its perimeter. Okay, so let's try this one, number 62. From the section on law of cosines, a surveyor has taken the measurement as shown in the figure. Alright, so we have our lake, and the measurement across to the two sides, which he doesn't know. Takes this distance like there. We have 70 degrees, 70 feet, 800 feet on this side, and 900 feet on that side. Alright, and we want to know to the nearest tenth. So this side right here, use the law of cosines, right? So this would be c squared is equal to 800 squared plus 900 squared minus 2 times 800 times 900 times the cosine of 70 degrees. Alright, so I can just plug that in my calculator. So we have 800 squared plus 900 squared minus 2 times 800 times 900 times the cosine of 70 degrees. Oops, gotta hit the right button. So we get 5,957,490,9936 That's what, 957,490. Now we have to just take the square root. Now instead of on the calculator, instead of typing all that stuff back in, I'm just going to answer, and I get square root, and I get 979 feet when I round off to the nearest tenth. Oh, it's nearest tenth, that's right. Sorry, slight mistake here. There. Now let's try number 71. This is one we're going to find, and we have the sides, we want to find the angles. Alright, number 71. Philadelphia is 140 miles from Washington, D.C. Washington, D.C. is 442 from Boston, and Boston is 315 from Philadelphia. Draw a triangle connecting these three cities and find the angles in the triangle. So let's draw our fake little picture here, but here's Philly, here's Boston, here's D.C. So we have our triangle, even though it doesn't look anything like it, because really they're almost in a straight line with each other. DC is really kind of would be over here, look something like this, but I'm just doing this to exaggerate the whole thing. Alright, so Philly and DC 140 miles apart. DC and Boston 442. And Boston and Philly is 351. So what we want to do is find the angles. So we don't have any angles, so we're going to use the law of cosines. So I take something like say we want to find this angle right here. We'll call that theta. So I have 140 squared is equal to 315 squared plus 442 squared minus 2 times 315 times 442 times the cosine of theta. So I solve this for cosine theta, so I subtract these off. So I have 140 squared minus 315 squared minus 442 squared divided by, because that's going to subtract all this over, so I just have to divide by all this. Negative 2 times 315 times 442, that's equal to the cosine of theta. So then what we really want to do is this is a positive number, we're going to have the cosine inverse, this is what theta is, of all of this stuff. So we would have 140 squared minus 315 squared minus 442 squared all over minus 2 times 315 times 442. Alright, so now we can just plug this into our calculator, and then parentheses for the numerator. 140 squared minus 315 squared minus 442 squared divided by minus 2 times 315 times 442, and we get 0.185. Now if I want to convert that to radians, I of course would just have to multiply it by, it is in radians. If I wanted to convert it to degrees, divided by pi. So this is about 9.1 degrees. Alright, so we get 9.1 degrees. Now, what I could do is do the same thing on this side, right? Do exactly the same thing we just did. I'm just going to call it phi for a different number. So that would give me 315 squared is equal to 140 squared plus 442 squared minus 2 times 140 times 442 times the cosine of phi. So if I solve this, for phi, this would be subtract these over, divide by that. Take the cosine inverse of all that, and then figure out what this is. Cosine inverse 315 squared minus 140 squared minus 442 squared. Oh, I forgot my other parentheses for the numerator. Let's go back in here. So this is if you have a TI or this app, really you can just go insert and parentheses and get it and put it in, which is a nice handy thing, so you don't have to like try to retype the whole thing. Parentheses -2 times 140 times 442, and that gives us our radian degrees, which then if I want to turn it into, or radian measure, which if I want to turn it into degrees, I take that number and multiply it by 180 and divide it by pi, and we have 20.7 degrees. So we have 20.7 degrees. Now, really all we have to do for the last one, I could do this all again, but for the last one I really just have to go 180 minus 9.1 minus 20.7. So that would give me 180 minus 9.1 minus 20.7. So that gave me, what did it give me? 150.2. And we have our three different angles. We have 9.1 degrees, we have 20.7, and we have 150.2. And this is an application of the Herons theorem because they're looking for the area. Number 78 says, find the area of a triangular piece of land that measures 110 feet on one side and 250 feet on the other side, and an angle of 85 degrees in between the two. Should look more like an almost right angle, but who cares? We just want the sides. Round to the nearest. Now, this one we need to use Herons theorem, so I need to find the S value, which would be, I need the third side. So to do that, I need to use the law of cosines. So this gives me c squared is 110 squared plus 250 squared minus 2 times 110 times 250 times the cosine of 85 degrees. 10 squared minus 250 squared. Oops, plus, sorry. I'm just getting ahead of myself there. Plus minus 2 times 110 times 250 times the cosine of 85 degrees. Take the square root of that. And we get 264. Let's just call it 264 just for rounding reasons. Okay, now that I've taken the square root and found the side is 264, now I can use Herons theorem. So I need to have S. So this is add up the three sides, 110 plus 250 plus 164, and divide them by 2. So let's plug this in parentheses because I want to make sure that I do the addition first. So I get 312. So now I have 312. So now I can actually find the area. The area would be the square root of 312. 312 minus 110. 312 minus 250, and 312 minus 264. So I plug that into my calculator. Square root of 312, parentheses, 312 minus 110 times 312 minus 250 times 312 minus 264, and we have 1395.2 feet squared.